Hi grade 10s, it's me again. Welcome to the video lesson. We're going to be working through this worksheet on Cartesian plane problems and I'm super amped. Let's get stuck right in. What does question 1 have in store? P is a point 3, 5 as shown in the diagram. Here's my beautiful triangle. Angle A is in the first quadrant. Work out the lengths of the triangle's sides. Okay, well, that's pretty easy. I look at my point 3, 5. Remember, this is a coordinate. X is 3, Y is 5. So this length, so O being the origin, that length OB will be 3. The length BP, vertical length, parallel to the y-axis, that will be 5. So now I just need to find my third side, the hypotenuse, the terminal arm. All right, so your hypotenuse squared is equal to your side squared plus your side squared. So OP squared is equal to 34. Now, 34 is not a perfect square. So if you try square root it, your calculator will say root 34, and if you change it to a decimal, it will say 5,83. But I just want to rather work with this surd. Okay, I'm not going to change it to the decimal. I'm just going to leave it as root 34. Cool, so we've figured out the lengths. If you did change it to a decimal, you would have 5,83 as your solution. All right, so I'm going to work with root 34. If you work with 5,83, that's perfect, not a problem. Determine the following ratios without using a calculator. Leave ratios as simplified fractions. Okay, so sine of A. So sine is, remember on the Cartesian plane, it's y over r. If you still want to talk about opposite over hypotenuse, that's perfect. Aren't we getting the same answer? So from your reference angle, sine is opposite over hypotenuse, y over r. So do you see why we don't have to use our calculator? We literally just look at the sketch. All right, so I'm just going to leave it. That can't simplify any further. That will be my final answer. If you wrote it as 5 over 5,83, that's no problem. All right, do you see we're not trying to solve the size of the angle. We are literally just writing down sine of A, what is the ratio? All right, for cos of A, so cos, usually we would say what? Adjacent over hypotenuse on the Cartesian plane, x over r, whatever we say, we're going to get to the same answer. So that will be 3 over root 34. Or some of you may have changed it to the decimal. So that would be your answer over there. Spot on. All right, what about tan of A? So tan, we would usually say tan is opposite over adjacent, or on the Cartesian plane, y over x. So tan of A is 5 over 3. All right, now D, E, and F is just our reciprocals. Can you remember which reciprocal links up? So sec is the reciprocal for cos. Cosec is the reciprocal for sine. So obviously that leaves cot and tan, right? So those are each the reciprocal for each function, right? So remember the reciprocal is you literally just flip your fraction over. So if sine of A is 5 over 34, cosec A will be root 34 over 5, or 5,83 over 5. You're literally just going to take those fractions you've already determined and flip them over. So for sec, whose reciprocal is cos, if cos of A is 3 over root 34, sec will be root 34 over 3, or 5,83 over 3. That's pretty easy. If tan of A is 5 over 3, well then guess what cot A will be? Flip them over. It's going to be 3 over 5. All right, so that's our first page done. This was pretty easy. Okay, let's go into page 2. Right, let's have a look. P is the point 1 root 3. Angle A is in the first quadrant. Okay, so we're still working in quadrant 1, where my x, y, and r value, all of those will be positive. work out the lengths of the triangle side. Okie dokes. So this is going to be 1. This length will be root 3. I just need to find the hypotenuse. So OP squared, the hypotenuse squared, is equal to side squared plus side squared. It doesn't matter which order you add the sides and square, right? As long as you are squaring each side and adding them together. So OP squared, if you square a square root, you just left with the number underneath. So root 3 squared just becomes 3. So OP squared will be equal to 3 plus 1, which is 4. So your hypotenuse length is 2. Remember, not plus or minus 2. The hypotenuse length, your terminal arm, is always positive. Cool. So we've worked out the length of the triangle. We've done this so that we can answer our follow-up question. So sine of A is y over r, opposite over hypotenuse. So that's going to be root 3 over 2. Cos of A, cos is adjacent over hypotenuse, or x over r. So that is going to be 1 over 2, which is a half. Tan of A, right? So tan is opposite over adjacent, or y over x, and that is simply root 3 over 1. I'm just going to write root 3 because that says the same thing, doesn't it? Yes. All right, now your reciprocals, just let's link them up. So sec is the reciprocal of cos, cot is the reciprocal of tan, and sine is the reciprocal, well, cosec is sine's reciprocal. So all we're going to do is flip those fractions over. So for sec is a reciprocal for cos. If cos of A was 1 over 2, sec will be 2 over 1. Or we could just write 2. Cosec is the reciprocal of sine, so let's just flip them over. If sine of A was root 3 over 2, cosec A will be 2 over root 3. And my last one, cot A, cot being the reciprocal of tan. If tan of A was root 3 over 1, cot A will be 1 over root 3. Okay, wow. This stuff's pretty easy, hey? Next page. So here's something a little bit different. Let's check it out. Line OP has been rotated in an anti-clockwise direction from the positive x-axis through an angle measuring theta degrees as illustrated below. Okay, so this line was flat on the x-axis. It starts moving anti-clockwise, right? We got to this point on the Cartesian plane, 12, 5. Right, angle theta has now formed between the positive x-axis and that terminal arm. Calculate the length of OP. Calculate the value of sine theta plus cos theta. All right, so I just need to do a couple of things to my sketch first. I'm going to make a right angle triangle. Okay, so we drop a perpendicular. Let's label our lengths. X is 12. The y value is 5. Right, theta is this angle over there. Right, that's theta inside there. I need to find my third side, and I'm going to find it using Pythagoras. So the hypotenuse squared is side squared plus side squared. The hypotenuse squared, so that's going to be 144 plus 25, which is 169. And the square root of 169 is 13. Cool. So the length of OP is 13. Calculate the length. Oh, okay. So obviously you would want to do that working over there. Or if you just write there, that OP is 13. Perfect. Okay. Calculate the value of sine theta plus cos theta. So we don't panic now. All right. So what is sine of theta? Sine is opposite over hypotenuse, y over r. So sine theta is simply 5 over 13. What's cos theta? So cos is adjacent over hypotenuse, or x over r. So that's going to be 12 over 13. And what's 5 over 13 plus 12 over 13? 17 over 13. That's it. That's all you need to do, grade 10s. That's your final answer. Well done. Let's go on to question 4. Oh, lovely. We've moved into a different quadrant. We've been working in quadrant 1. Boop. We flipped over. We're in quadrant 2. We've got the point P. Negative 6, 8. Remember that x is now negative because we're on the negative x-axis. Y is positive on the positive y-axis. Angle A is shown. We're in quadrant 2. Work out the length of the radius AP. Okay, so we know that this length OB is negative 6. This length is 8. Third side, Pythagoras. So hypotenuse squared. You're going to be so good at Pythagoras after all of this, right? If you aren't already. So AP squared. So that's going to be 64 plus 36. So that's going to be 100. So AP is going to be equal to 10. Awesome. So 6, negative 6, 8, and 10. Those are my 3 lengths. 4.2. Determine the following ratios. Okay, well, this is the same as before. Just now we know that some of our ratios are going to be negative, right? Because who can remember now which function is positive in quadrant 2? It's sine, right? C-A-S-T from your cast diagram. So we're expecting sine and its reciprocal cosec. We're expecting those ratios to be positive, whilst cos and tan are going to be negative. So you can even check your work. So sine of A, right? Opposite over hypotenuse. So y over r, 8 over 10, which is 4/5. Okay, it does say simplify your fractions. Cos of A, so that is adjacent over hypotenuse, or x over r. So that's going to be negative 6 over 10, which is negative 3/5. Tan of A, that's y over x, opposite over adjacent. So y over x is 8 over negative 6, which simplifies to negative 4 over 3. So what I said earlier checks out. Your ratio for sine is positive, whilst cos and tan are negative. And that's what we're expecting to happen in quadrant 2. All right, reciprocal. Sec is the reciprocal for cos A. So I'm just going to flip over that simplified fraction, right? It's going to be 5 over negative 3. Remember that sec is the reciprocal for cos of A. So I just took that fraction there and flipped it over. Cosec is the reciprocal for sine. So if the simplified ratio for sine was 4/5, for cosec, flip it over. 5 over 4. Amazing. And then the last one, cot. So cot is a reciprocal for tan. So if the simplified ratio for tan was negative 4 over 3, for cot it will be negative 3 over 4. Oh my word, this is so basic. Let's see what the next question has in store for us. Awesome. We are now in quadrant 3. In quadrant 3, I'm expecting my ratio for tan to be positive, sine and cos will be negative. I know they're already going to ask me work out the length, so let's just get into it. This will be negative 5. This will be negative 7. Remember, I'm looking at the coordinate given. That's how I'm getting these lengths. I need to find the hypotenuse. So AP squared is equal to negative 5 squared plus negative 7 squared. Remember that you're squaring the negatives. So these come out as positive values. So it's going to be 25 plus 49, which is 74. Am I correct? So therefore, AP will be equal to, so now if you type root 74 on your calculator, right, it doesn't square root to a whole number because it is not a perfect square. I'm going to work with root 74. If you changed your number to a decimal, so if you worked with 8,60 or just 8,6, that is spot on. You're not wrong. I just prefer working with the surd. It's actually more accurate because the surd contains all the decimals, whereas 8,6 we've actually rounded off. But if you work with that, it's not a problem. But let's get in the habit of staying with the surds. Okay, So I figured out the radius, the length AP. So they're asking us to do the same stuff here, right? Determine the ratios without a calculator, simplify. All right, and I'm just laughing and thinking, oh my word, this is just the best. So sine of A from here, opposite over hypotenuse, or y over r. So that is negative 7 over root 74. Or if you wrote it as the 8,6, all good. And I'm happy because my ratio is negative, and I know that this is tan's quadrant, so sine should be negative. Cos of A, so I'm also expecting a negative answer. X over r, or adjacent over hypotenuse. So negative 5 over root 74, or negative 5 over 8,6. Either would be accepted. Next one, so tan we know is positive in quadrant 3. Opposite over adjacent, y over x. So negative 7 over negative 5 becomes 7 over 5. Awesome. All right, so now for the reciprocals, grade 10s, we literally are just going to identify which reciprocal goes with which of the original trig functions and then flip that fraction over. So sec is the reciprocal for cos. So it's going to be root 74 over negative 5, or if you said not root 74, or if you said 8,6 over negative 5, that is perfect. Cosec, that is the reciprocal for sine. So if sine of A was negative 7 over root 74, we're just going to flip that fraction over. Remember, if you used 8,6, not a problem. Last one, cot is the reciprocal of tan. This is the only function that is positive in quadrant 3. So if tan was 7 over 5, cot will be 5 over 7. Hooray! Oh my word, I'm just enjoying this worksheet so much. And we're nearly done. All right, you smart, beautiful creatures. Let's keep going. Question 6. Kimmy makes the following statement. Since cos of 60 is a half, cos 300 must be equal to a negative half. Without the use of a calculator, decide whether Kimmy is correct or not, and give a brief explanation of your reasoning. Okay, well, I do not want you to just punch sine 300 into your calculator, please. It even says don't use your calculator. So I'm going to explain this to you using the cast diagram, and then we can just jot down a couple of sentences. So we know the cast diagram now is going anti-clockwise. We've got quadrant 1, 2, 3, and 4, and C, A, S, T, right? Representing the trig function where it is positive. So cos of 60 equals a half. We know that that is true. We've been practicing working with that angle quite a bit, and that would be correct. It's the cos 300 that we need to look at. So 300 degrees, you'll agree with me, is in quadrant 4, right? Between 270 and 360 degrees. It definitely falls into quadrant 4. Remember that this quadrant is the 360 minus theta quadrant. So 360 minus what is the same as saying 300. If I rewrite cos 300 as cos 360 minus 60, right? 360 minus 60, that's saying the same thing. Those are equivalent. And we reduce that down to the acute angle cos of 60. And we know that this is positive since we're working in quadrant 4, which is where cos is positive. So cos 300 is actually the same value as cos of 60. All right, so therefore Kimmy would not be correct in their deductions there. Cos of 300 is equal to cos of 60. They are both a half. So if you wanted to jot down a sentence, just talk about the fact that you're working in quadrant 4, that cos is positive in this quadrant, so therefore any ratio that is formed in quadrant 4 must be positive. So basically we can just say cos theta is always positive in quadrant 4. Right, we can just say something like that. Cool. Let's have a look at question 7. As you know, sine of 45 is root 2 over 2. Find a different angle beta for which sine of beta is also root 2 over 2. So it's very similar to the above question, grade 10s. It's not different. I'm not going to worry now about that beta sign. So, cast diagram. Right, where is sine positive? In which two quadrants is sine positive? Well, I know in quadrant 1, obviously, the all quadrant, all my functions are positive, and in quadrant 2, right? Because quadrant 2 is sine's quadrant. It's where it's positive. This is the 180 minus theta quadrant. So sine of 45 would be here in quadrant 1, right? We know that whatever angle we find, it needs to fall in quadrant 2. It needs to fall between 90 and 180. Why? Because the ratio formed is positive. So if the ratio is positive, I have to be working in a quadrant where that function is positive. So with sine, in this case, it's going to be in quadrant 2. So the question is, well, so what is that angle? We need to work with this 45 that they gave us. Because we know that whatever they subtract from 180, right, is going to reduce down to that angle. And I wanted to reduce down to 45. So we're kind of working backwards compared to the previous question. So if we start off with sine 45, all right, and I said if we reduce down to 45, so it was sine 180 minus 45, right? So sine 180 minus 45, if you simplify that, it does become sine 45. But the question is, so what is actually this angle? That's the beta over there. So 180 minus 45 is 135 degrees. So sine of 135 is equivalent to sine 45, right? Which is, you can even test that now. So if I said sine 135 equals root 2 over 2, you could check. So 135, that falls into quadrant 2. It's between 90 and 180. That's the 180 minus theta quadrant. How can I rewrite 135? 180 minus 45, which becomes sine 45. Boom, we're done. Okay, so your answer for 7 is beta must be 135 degrees. Question 8 says, challenge. It is given that cos of alpha is 4 over 7. So we've got different pieces of information here. Right, there's one. And alpha lies between 90 and 360 degrees. Okay, so this inequality is saying the angle alpha is between 90 and 360 degrees. Without a calculator and with the aid of a diagram, find the value of sine alpha. So I said we have two pieces of information, and I think I'm going to use different colors for my different pieces of information. Okay, we've got the fact that we've got cos alpha is 4 over 7, and that alpha lies between 90 and 360. It asks us to use a diagram. So I'm going to draw a Cartesian plane for myself, and I'm going to label my quadrants. I'm going to make my life easy. All right, so this is quadrant 1, 2, quadrant 3, quadrant 4, and the cast diagram C, A, S, T. Now, I'm literally going to tick off from the information given, which quadrant would that information fall in. So I'm going to start off with the cos alpha is 4 over 7. So the ratio is positive. So the quadrants where cos is positive is in quadrant 1 and 4. The second bit of information. So I just need to quickly pop all my degrees on the Cartesian plane. 0, 90, 180, 270, 360, moving anti-clockwise. So we are now going to mark off the quadrants which fall from 90 to 360. So quadrant 2, 90 to 180, quadrant 3, 180 to 270, and quadrant 4, 270 to 360. Do you notice that in this quadrant, it's the only place where I have 2 ticks? So it's where information overlaps. And it's in that quadrant that we are going to draw our right-angled triangle. Okay, so I'm just going to scooch this up a bit. So I'm going to draw that radius, that terminal arm from the origin out like that. And I'm going to make my right-angled triangle. Perfect. Okay, there's my 90. There's my angle theta. Well, what did they give us? They didn't say theta. They want us to use alpha. Okay, so cos of alpha is 4/7. Cos is adjacent over hypotenuse, or x/r, right? So let's fill in our lengths. The adjacent length from here, your x value, will be 4, and the hypotenuse is 7. So we need to figure out what the y value is, because remember now we've got a point P where x is 4. I need to find out what that negative y value is going to be. And guess how we find it? Pythagoras. Except now we're looking for a side and not the hypotenuse. So the side squared is equal to your hypotenuse squared minus your side squared. So we just rearrange the Pythagorean formula so that we can make the side we're looking for the subject of the formula. So the side squared is equal to 7 squared minus 4 squared. So that's going to be 49 minus 16, which will be 33. So therefore your side is plus or minus root 33. So it's the first time I've ever done plus or minus when I square rooted so far in the 2 videos we've looked at today, because I'm now dealing with a side, right? So the sides can be positive or negative depending on where we are on the Cartesian plane. So this is a negative y value because we are parallel to the negative y axis. So negative root 33 will be the length for y. If you change that root 33 to 5,74, if you want to do rather work with a decimal, as I mentioned before, that is fine. I just prefer sticking with the surds. So if you wrote this then as 5,74, well, remember it must be negative 5,74, that's perfect. Okay, so yes, it was plus or minus because I square rooted, but then because of where I am on the cost diagram, because I'm in quadrant 4, my y value is negative. So now I can answer the question. Find the value of sine alpha. So sine is opposite over hypotenuse, y over r. So sine of alpha is negative root 33/7, or some of you may have written negative 5,74/7. All right, both will be accepted. Both is fine. Okay, so that's actually not so bad. This overlapping information is obviously what's crucial because that determines where you draw your right-angled triangle. All right, last one. Using a diagram, prove that sine 180 plus theta is equal to negative sine theta. Okay, so let's just have our cast diagram. CAST, we're going 0, 90, 180, 270, 360. And let's just pop our quadrants up. So we're working in quadrants. We've got quadrant 1, 2. Do you see how valuable this thing is? It crops up all the time. Okay, so the 180 plus theta quadrant is quadrant 3. All right, remember that quadrant 3 is Tan's quadrant. Okay, so we know that in quadrant 3, so we could say like in quadrant 3, sine is negative. So you can say therefore sine 180 plus theta equals negative sine theta using reduction formula. Maybe something else we could do if that doesn't take your fancy, or perhaps what other people did was they drew that terminal arm, the radius, right? They drew from the origin, they created a point, right, that it would have labeled this point as, so the x values are going to be negative and the y values are going to be negative because where we are on the Cartesian plane. So perhaps somebody would have said that since sine theta is equal to negative y over r in quadrant 3, therefore sine 180 plus theta equals negative sine theta. Yeah, just something along those lines I think is more than good enough. And yeah, it just really reinforces this idea that we've learned previously. Using our reduction formula, I'm in quadrant 3. Quadrant 3 is where tan is positive, not sine. So when you do reduce down to the acute angle, you are expecting it for the ratio to become a negative. All right, good job, grade 10s.